developed by me in Robert Gordon University and Davide Lombardi at Sian Yaltong, Liverpool. I should try and get this one. So, for those of you that have never heard of Bitcoin or Ethereum, these are what we call now cryptocurrencies, basically currencies that are, they use a distributed database all over the internet to operate. You will hear a kind of counterintuitive term about those currencies called they are trustless, which basically means you don't need to have a bank, you don't need to trust someone else to tell you whether another person holds the currency. And the way they operate is they operate using a distributed ledger. So imagine this as a database that is split into blocks. You can see some of this here. Each block contains a block header. It also contains a hash and a numbering system, so you can have block number 1, block number 2, and so on and so forth. In each case, the next block contains the encryption hash of the previous one, hence the term blockchain. And you can use Merkle trees, which are encrypted trees, where each successive node contains the hash of the encryption of the 2 previous ones, to kind of verify whether the copy of the blockchain that you have in your hands actually tells the truth about someone having money or not. Okay? So imagine that instead of going to the bank to ask whether someone does have the money, you basically ask everybody around you to verify whether someone holds currency or not. And here, for example, the green rectangle is asking all of the other blockchains to check the records so that they verify whether the blue rectangle actually holds any currency in a transaction to receive it. Now, why is this important for the built environment? Up until now, we've only been discussing currencies in a distributed fashion. You potentially have heard a lot of speculation around the value of Bitcoin and so on and so forth. But what is interesting is if you actually take a look at the second most kind of famous cryptocurrency, which is called Ethereum, and that's a network where you can actually also run smart contracts. So within the blockchain, you can actually encrypt a contract that would be, you can be bound by law, and you can develop a kind of way where you execute contracts automatically without having to go through a negotiation process and so on and so forth. Now, we ran into this, me and Davide, by working in a competition last year where we designed a new city in China, in Yilong, in Guizhou province, which was set by the Chinese government as one of the big data and blockchain centers within China. A lot of the things that the Chinese government is doing in terms of strategies, they're trying to kind of themify some of the new urban centers that they are creating. So we thought to try and use the large computer data centers within the city and kind of exploit the heat that gets generated by processing the blockchain to actually heat part of the city. And after the competition was over, where we won the 3rd award out of 1,000, we started to look at whether the idea of using the blockchain within our computational tools actually had any kind of merit, because initially we were thinking about it in kind of conceptual manner. And I kind of remembered a protocol that was developed in the auspices of an open source project called Verse, where basically you would collaborate with other people in real time and you would do transactions irrespective of whether you were using BIM or CAD or Blender or any other kind of software. So they were able to kind of solve a classic problem in collaboration between designers. And we started thinking that could we find a way to use the underlying technology of cryptocurrencies and connect it with CAD, with CAD and BIM, in terms of the potential that the smart contract paradigm would have in execution in the built environment. And we kind of identified 4 levels of where we could actually try to integrate that. And one is you have a blockchain running inside a CAD software, which is rather simple. Then you have a second level where a CAD system is connected with the blockchain through the web. And a third and fourth level, which gets a little bit more complicated, where the CAD system participates in the blockchain directly by controlling one of the Ethereum nodes. And the fourth one, which would be that the CAD system is directly running on a blockchain. So the database of the CAD system is actually a blockchain rather than a simple database. And after we kind of conceptualize that, we run a very simple blockchain within Grasshopper on Rhino. It's very easy to do. You can download open source code, run it on Python, and then you can have Grasshopper basically generating the nodes. Obviously, it's just a proof of concept. It doesn't do anything useful from that point of view other than just showing that it works. And then we try to implement the second level of integration, and this is what you can see here. So we suppose that the computational designer is trying to find out which is the highest point on a curve, and then after running through an optimization algorithm, actually send those values, the optimized values, over to a blockchain to have a smart contract executed. So you see the definition in Grasshopper, and then we use Growl basically to communicate with a Node.js server, which is basically a web server that then communicates with an Ethereum blockchain. And then as soon as you find an optimized value and you send this to the simulated, obviously we didn't use for computational simplicity, we didn't use the real Ethereum blockchain, but the simulated one, and then you can basically get paid as soon as you find the optimum value, as you can see in this simulation. And then you have a record of which block was the one that actually executes the smart contract. And very simply, this is a kind of cyclical diagram that shows that you have a computational designer that has an Ethereum address that's kind of like your bank account. You basically execute an optimization problem, you find an optimized value, send it to a web host, and that communicates to Ethereum that it can execute a smart contract. And if you have any kind of money, you can actually pay the computational designer from that point of view. Now, we still have the level 3 and level 4 to go, and we're working with Davide on this. A kind of discussion on what we're trying to do for the future. It would be fantastic if anyone has any questions or observations. We can go with them over coffee. So the first idea is to try and write code and have it ready for both private and public networks, so both blockchains that potentially you don't want to be in the public, but at the same time you want them to be distributed as a kind of redundancy mechanism. Think nuclear plants or similar infrastructure. The second thing we're trying to do, and in this we're trying to collaborate with a couple of other colleagues, is implement direct BIM to blockchain integration, so that we look into building operations and maintenance. So how do you use BIM and a digital twin with a real existing building, and then you can use blockchain basically to record whatever happens within the existing building. And then a fourth one, which is kind of like a pet project of mine, to develop a decentralized autonomous organization, as I said, grammarist. That would basically mean that people all over the world would kind of coalesce together and try to develop collectively a safe grammar, and through that they would record all of the actions within a blockchain, thus giving you kind of a percentage or an identity to who developed which rule and so on and so forth. And from that point of view, you can actually kind of make collaboration a lot more trustless, in the sense that you won't need to negotiate. You will just basically try to use the blockchain as a kind of means to collaborate. And if you have any questions.
Thank you for the presentation. So, any question? Well, it's an interesting topic, and I have just one quick question.
Please.
I'm really interested in, well, if you can tell us a bit more about, the potential in interconnecting CAD and BIM tools with the economic life. So if you can tell us something more.
Okay, so this is exactly where it started from and what we're trying to explore. And the main idea is to try and provide meaningful mechanisms to be able to connect a lot of the value that we are creating as researchers and designers. Think that, for example, you could build a grasshopper definition, and then you could actually connect this with a blockchain market and then sell your definition and then gain money out of it. I mean, that's a very direct example of what you could do. Another thing we're looking at is, when we're talking about BIM and blockchain, is actually trying to see how we could kind of streamline and make maintenance transparent. And if you take this to the level of the city, one example I always give is, if you have, for example, companies that are paying business taxes to the city council, let's say they are able to create a lot more energy, be more energy sufficient, and with a blockchain you can prove this and then pay less taxes if you are, better to the environment,
Yes.
for example. So you can think of a lot of scenarios like that. The one tricky part is the computational complexity. So a lot of it actually needs, let's say, you need money to make money from that point of view. So you need a kind of complicated computer network to run all this.
And do you think that there are more opportunities in Asia, for example, or in Europe, or is the same?
I can speak for China because I was there for 6 years. So China was a paradise for all of the people that were mining blockchain and Ethereum because they were subsidized by the Chinese government. The problem with cryptocurrencies is that there is no central control of the currency, and this the Chinese government didn't actually like, so they basically banned everybody from doing that. If you live in a very cold climate, like Aberdeen in Scotland, it's very nice to do that because you don't have the problem of heating up all of your equipment while you're working there. So you will see right now that most people that work on cryptocurrencies, they go to Iceland, Norway, Russia, up north. So anywhere with a lot of cold and a lot of money is actually a good place to do so.
Okay, thanks. Any other questions? Yes, please.
And I was wondering that if there is any place for arguments if you use blockchains. I mean, because usually in these BIM projects, the copyright is a big issue. That who participated in the project, what did they add to it, and if it is automated, then who is there a judge who maybe can afterwards?
Well, exactly. That would be the main point in discussing, for example, I mean, God forbid, liability in a built environment project. So you would be able to actually see who did which change to the model, and you could both apply responsibility or give them more money, or you could apply liability. So take them to court because they made a mistake. Mm-hmm. And that kind of, I mean, if you think about it, it has a chilling effect in one sense, but on the other sense, everything that you do is transparent, so you need to operate in a kind of much more efficient manner.
Yes, thank you. Any other question? Okay, thanks
Thank
a lot again. Thank you.